Hi everyone, we are back a bit, in one of the new subject that is going to be electronic devices. Okay, so we are back here after mathematics. I was planning, in fact, many students asked me that, sir, please start electronic devices. Okay, so I will be, from now onwards, I will be talking about semiconductor fundamental and introduction to semiconductor devices. Okay, so primarily I'm going to focus on semiconductor fundamental. If you understand the semiconductor fundamental, or you can say the building block of semiconductor fundamental, then you can in fact fabricate any device, can talk about any electronic devices. Okay. So today is going to be just an introduction. So I will be telling you what is my course plan, how we are going to go ahead, and what will be our reference, which reference book you should follow. Okay. So guys, let me assure here only that if you honestly attend my session, you will in the gate examination you will boom, right? You will completely score complete marks. Remember, okay, you will get complete marks from electronic devices. Okay, in fact I will be helping you understand the problem solving, right? How to solve any problem if any question is given from electronic devices, right? So if you are good at fundamental, everything is gonna be simple and easy. So welcome to my course. Okay, I think everybody knows my name as well. My name is Dheeraj, and I think, yeah, everything seems okay. So my voice is audible. Yeah, good evening, Ayush, right? So I'm waiting for everybody to join here. And from today onwards, I will be talking about semiconductor fundamental. Okay. So what is my course plan, and how we are going to go ahead? Everything I will be discussing. Okay, in next 10 to 15 minutes, and you guys have to follow these lectures very honestly and carefully, and we will also solve various problems from different textbook, right? So this course will be basically for electronic devices, remember. Okay, so wait a minute here. I think 1 minute. Okay, so we are back here now. So I hope everybody has joined us, right? So in fact, I have shared the link as well. So this course will be on this course is going to be on electronic devices. Okay, electronic devices. I'm not going to talk anything about circuits, right? So yeah, hi Tanis, yes. So I will not be talking about anything about you know the you can say what you can say talking about circuit, because I will be taking separate course on circuit, that will be the analog circuit, right? So this course is very advantageous for everyone, in fact, who is dreaming to get into VLSI, as well as who wants to become VLSI engineer, right? And who wants to get into semiconductor companies, right? So electronic devices, primarily what I'm supposed to do here is I will be talking about fundamental of semiconductors. Okay, fundamental of semiconductor. Okay, so if you understand the fundamental of semiconductors, your life will become very easy. Okay, without understanding semiconductor fundamental, you can't understand anything. Okay, so one of the Nobel laureate also says, right, uh, if you go through electronic devices, okay, if you go through electronic devices, and there is one tool, that tool I will bring here. Okay, uh, as I teach any topic, you guys know that I always tell something, some weak point, or you can say some strong point, right? So that you can start thinking. Okay, so there is one tool, in future you will come to know that that tool name is energy band diagram. Okay, so entire course will be taught using the energy band diagram. Okay, If you know the energy band diagram, your life will be very easy. You don't have to mug up any formula, anything, right? So in fact, we will start the session from energy band diagram itself, okay? Because one of the scientists, one of the Nobel laureates says that, okay? From where I came to know this, one of the professor, I was attending his session, so he said that, okay, one of the Nobel laureate, he said, if you're not teaching semiconductor physics, or you can say electronic devices with the help of energy band diagram, right? So then you don't know about electronic devices, okay? You will not find anywhere people emphasize on energy band diagram, and most of the time when you go for the interviews and everything, you fail to clear the interview. So I hope my voice, Tanisk, and everyone is clear, right? So I will be starting with the semiconductor only, right? The fundamental semiconductor physics, okay? So my course will be divided into two halves basically. Okay? The entire electronic devices will be divided into two halves. Okay, this course. The first will be the device physics. Okay, so here I'm going to talk about device physics. Okay. The moment you understand the device physics, we will be able to understand the devices, and we will talk about electronic devices. Okay, all the electronic devices which we will come across, okay, will be made up of semiconductor only. Yes, perfect. So I will also ask that why do we need only semiconductor? See, there are various material, we have got insulator, we have got metal, we have got semiconductor, right? But why only semiconductor is so important in our life? Okay, that you should know. Because if you're from electrical engineering, suppose you're from electrical engineering, so you study power electronics, okay? And you also study about diodes, PN junction, there are many concepts, right? But nobody knows why we use semiconductor. Why being an electronic engineer always talk about semiconductor? Why we are not talking about metal? Why we are not talking about, why we are not talking about insulator? There are many questions. So can somebody write on a chat box, why do we need only semiconductors? Yes, anyone? Why do we need only semiconductor, guys? What is the main what is the need of semiconductor? Why do we only need semiconductor, okay, to understand electronic devices? Yes. So I will be dividing entire course into two parts. One will be the device physics and one will be the electronic devices here, okay, all kind of devices you can say. So in device physics, we will start with the band diagram, okay. We'll start with the energy bands, you can say, okay, energy bands, and there will be many questions, okay. What are these bands, how bands are formed, okay. There are many questions, how bands are formed, okay. And after that we'll talk about electron hole, okay, electron and holes. What are these electron and holes, okay. uh, so in device physics, these are the basic building blocks, okay. You need to understand why do we need bands, why we are talking about bands, how bands are formed, हाँ? ये बैंड्स कहाँ से आते हैं, कैसे फॉर्म होते हैं बैंड्स, ठीक है, ये सारी चीजें आपको पता होनी चाहिए. Arjit is saying it can control the flow of current in devices, okay. So any other reason? This is, yeah, this is one of the reason that you can tell, but metal cannot do the same. Can you answer the same? Okay, it can only control the flow of current in the devices, semiconductor. So there are other material as well, okay. So you should give valid reason, right? So we'll talk about bands. So we always see valence band, conduction band, okay. The difference between the age of the conduction band and the valence band, that is energy gap, but we don't know what is the significance of these bands, okay. आप लोगों को ये नहीं पता होता कि बैंड्स कैसे आते हैं, कैसे बनते हैं, राइट, हाउ दीज बैंड्स आर फॉर्म्ड, what is the basic idea behind these band formation, right? And what is this energy gap, okay, why this parameter is so important in entire semiconductor physics, in entire electronic devices. This energy gap is one of the very important parameter, okay. So please keep in mind, in energy band we'll talk about energy gap. Okay, this is one of the, you can say, parameter, okay, which help you classify the material as well, right? Okay, which help you uh, in fact stand semiconductor as a great entity, okay, one of the great material, one of the best candidate. Arjit, because semiconductor has negative temperature constant. See, in the exam, suppose any professor is asking why do we need semiconductor, right? Don't tell all these things, otherwise they will ask what is the meaning of negative temperature constant, all these, so you will always be in the loop. Okay, you should know the basic. Okay, why do we need semiconductor, why semiconductor is so important, right? uh, to fabricate devices, so you should not tell all these things, otherwise they will ask what is current, then you will say sir current is this, then they will ask something, so you have to tell something where no question can be arisen, right? So you the professor will get satisfied. Perfect. So we'll talk about energy bands. Okay, and all the time we have to emphasize here, why bands, how bands are formed, right? This kind of questions you have to ask, how bands are formed. Okay, how bands are formed. And we'll talk about electrons and hole, what is the significance of electrons and holes, right? And we'll talk about one of the very important phenomena, that is doping here, right? The doping in the semiconductor. Okay, what is the meaning of doping? And we'll talk about statistics here, right? Okay, we'll talk about statistics, that is known as Fermi-Dirac statistics, right? Fermi-Dirac statistics. Now the question is, why do we need Fermi-Dirac statistics? Okay, Fermi-Dirac statistics. What is the need of Fermi-Dirac statistics, right? Uh, then we'll talk about density of states. Okay, after this we'll talk about density of states. I'm just listing these topics. Okay, density of states. Okay, and combining Fermi-Dirac. Okay, Fermi-Dirac plus, you can say, DOS, density of state. We'll talk about concentration. Okay, concentration of electron and hole. Okay, so you guys may not be familiar with this. If you know the density of state, if you know the Fermi-Dirac distribution, okay, if you combine them, you can calculate the what? You can calculate the concentration of electron and hole, right? But if you only take Fermi-Dirac distribution, right? Fermi-Dirac distribution function, that can only tell you whether electron exists or not, right? The probability of existence of electron in the material, right? In the semiconductor, you can say. Okay, but if you combine density of state as well as Fermi-Dirac, that is going to help you determine what the concentration of electron and hole. ठीक है, ये याद रखना. तो ये दोनों को हम कंबाइन करके सीखेंगे कैसे concentration फाइंड करते हैं. ठीक है. After that we'll talk about, these are the basic thing. Okay, after that we'll talk about transport. Okay, you can say transport mechanism we will talk. Why do we need transport of charge carriers? Okay, transport of charge carriers. Okay, why do we need transport? Because at the end of the day we want current to flow through semiconductor, current to flow through devices. Okay, if current will not flow, then there is no use of devices. Okay, so the transport, when charges will move, the current will flow. Okay, so after learning transport mechanisms, right, there will be different kind of transport. The first will be, can somebody tell me what are the transport you have heard till now? Charge carrier, how charge carrier moves inside the semiconductor. Okay, what is the natural phenomena that occurs inside the semiconductor? Because of that, transport mechanism happens. The charge carrier move inside the semiconductor. there are two kind of transport basically we will see here. One will be the drift transport, because of drift, electron and hole will move, right? And we'll also see the diffusion. Okay? Diffusion and drift. And diffusion is one of the natural phenomena. Okay, I will talk about what is the meaning of diffusion. ठीक है, तो ये basic concepts हैं that you should know before we start everything. So we will learn all these things, right? Okay, and then here also we'll talk about carrier combination. Okay, carrier recombination. Okay, carrier recombination. Okay, carrier recombination, there will be one important recombination that is known as SRH recombination. ठीक है, so many concepts we are going to discuss. So this is all about fundamental. Okay, the semiconductor fundamental. So if you are good at semiconductor fundamental, then your life is very simple. And after that we'll come to devices. Okay? We'll come to devices. So under devices we are going to talk about the basic device, that is p-n junction. Okay, the p-n junction. Then we'll talk about, this is the basic building block. Okay, you can say basic building block, okay, of all the electronic devices. If you're good at semiconductor physics and if you're good at understanding of p-n junction, okay, then you can do anything. Many people think that we take p type of semiconductor, we take n type of semiconductor and we join them. No, this is wrong concept. Okay, this is very bad way of telling. Okay, you will find in the YouTube channel. Okay, you take one single semiconductor. Okay, you dope one side n type of impurity, you dope one side the p type of impurity, right? And that forms a junction. Okay, that will form a metallurgical junction and that will be known as p-n junction. Okay, never think that you take p type and you take n type and you combine them. This is one of the paradox. Okay, one of the very big mistake people, okay, when they learn, they think that okay, p type is formed because of some doping. Okay, we'll talk about all these concepts. And n type is formed because of some doping, and we are combining, we are combining them, so it is forming a junction. No, we are taking one single slab of semiconductor. एक पूरा semiconductor लेंगे, इधर हमें क्या करना है, part of the semiconductor we have to dope some kind of impurity. We have to dope some kind of impurity. There are different kind of impurities which will come across. ठीक है, I hope this makes sense. ठीक है, so p-n junction we will discuss. Then we'll talk about MOS. Okay, basically we'll talk about MOSFET. Okay, the heart of MOSFET will be basically the MOS capacitor. Okay, MOS capacitor. We'll talk about MOS capacitor. MOS capacitor is one of the very important concepts. Like just like p-n junction. If you know p-n junction, you can better talk about BJT. Okay, the bipolar junction transistor, right? So we'll talk about bipolar junction transistor. So how to understand BJT? Okay, how to understand BJT, bipolar junction transistor? If you're not good at p-n junction, you can't understand bipolar junction transistor. To be able to understand BJT, okay, the prerequisite is to be able to talk about p-n junction. Okay, all the parameter which we will we'll take out from the p-n junction. Like we'll talk about built-in potential, we'll talk about different kind of junctions, step graded junction, linearly graded junctions, electric field we'll try to calculate. Okay, so many things. Okay, and there is one important equation which will help us analyze the entire p-n junction. Can somebody tell me what is the name of that equation which will help us to analyze the p-n junction, which you might have seen in electromagnetics? Anyone? There is one important equation that is going to help us analyze p-n junction. Arjit, can you tell me, or Ayush, or anybody who are watching us? So Yes, what is that equation? ठीक है, we'll talk about some of the optoelectronic devices as well. Okay, optoelectronic devices. So there will be different kind of devices. We'll talk about solar cell. Okay, solar cell. We'll talk about LED. Okay, we'll talk about photodiode. Okay, so what we are going to do here is, in this entire series of lectures, we will understand the fundamental first, the semiconductor fundamental, a primer. Okay, a semiconductor fundamental. If you're good at semiconductor fundamental, why I'm all the time talking about semiconductor? Okay, that this question is still not answered by anybody. Okay, that you have to answer. And we'll talk about high speed devices, high power devices, so many things. Okay, in fact, devices will be also used to to design memory, logic memories. There are many things. In fact, when you talk about digital circuits, okay, there also we use semiconductor memories. Okay, so we talk about semiconductor, right? So semiconductor plays an important role. Okay, semiconductor plays an important role. Perfect. Now we'll come back, okay, to talk about what references we are going to use. The references we will use is the period, right? RF period, you can see. Okay, the name is the fundamental of semiconductor. Okay, what we are going to do here is, we will be solving question from this book. Okay, all the question we will solve, and you will find each year the question from this book only, that is RF period. Okay, if you understand the concept, be it ISRO एग्जाम और गेट एग्जाम, कोई भी एग्जाम दे लो, सारे क्वेश्चन यहीं से आते हैं. ठीक है, एक और बुक है जिसको हम लोग रेफर कर सकते हैं फॉर प्रॉब्लम सॉल्विंग, दैट इज नीमन. ओके, डोनाल्ड ए नीमन, राइट? In fact, this book I used to suggest before, 5 years back, okay, in 2018 and 17, you can say, right? So Niemann will be preferred only to solve the question, but concept we will take from the RF period. Okay, this is one of the boon session for electronic people. But if somebody is from electrical engineering, right, they are interested for VLSI in future, or they want to dive into semiconductor physics, semiconductor devices area, okay, in future, like they want to get into TSMC or global foundry kind of a company, right, Intel, so they can take this course. ठीक है, उनके लिए बेस्ट है. Okay, so why semiconductor is so important, and the weightage, if I talk the weightage of this subject, you will be finding around 10 to 12 marks. Okay, so weightage always is 10 to 12 marks. Okay, 10 to 12 marks. Okay, and this course will be, and the tool which we will use always is the energy band diagram. Okay, energy band diagram. Everybody should know how to draw an energy band diagram for any kind of semiconductor devices. Okay, कोई भी semiconductor device अगर हम बताते हैं, you should be able to draw the energy band diagram. And if you are able to draw the energy band diagram, then what you can do? You can always what? You can always talk about different parameters. ठीक है, ये याद रखना. This is very important. Okay, statement that I always give. Okay, so in fact I have also put this statement in my one of the community post of YT, right, that you can always check. Okay, so in fact I will bring also that point. Okay, so the tool to understand electronic devices will be what? Energy band diagram. Now let us come back to the question, why semiconductor? Why semiconductor? This is one of the very big question, and I have been across country, all the places I have been, हर जगह मैं जा चुका हूँ इंडिया में, जहां भी गया सबसे पहला क्वेश्चन क्या है, why semiconductor? Nobody was able to tell. Okay, ऐसा क्या स्पेशल है सेमीकंडक्टर में which is standing separately among all the material? Yes guys, tell me. Okay, the semiconductor is one of the incredible thing that is shaping the entire world. Okay, you might have seen guys, आप लोग देखे भी होंगे चारों तरफ, अगर आप जाते हो, आप स्मार्ट सिटी की, पीपल आर टॉकिंग अबाउट स्मार्ट सिटी, राइट? स्मार्ट सिटी की लोग बात करते हैं तो आप देखते हो कि व्हाइट एलईडीज आर देयर। पहले क्या होता था, वो जो येलो कलर के बल्ब्स आते हैं, राइट? नाउ व्हाइट एलईडीज आर देयर, ठीक है? आप कहीं भी जाओ, हर जगह सेमीकंडक्टर है। टुडे यू आर एबल टू टॉक विथ मी, यू आर एबल टू वॉच माय सेशन बिकॉज ऑफ सेमीकंडक्टर, ठीक है? Don't tell me that the current it supports, or you can say it has negative temperature coefficient or something. You should be able to tell the real life examples, ठीक है? Why semiconductor, ठीक है? So semiconductor you will find across all the all the applications. Okay, mobile applications. If you see mobile, we always use mobile from the front, we never look back. उसके पीछे क्या है, we never look. Okay, what kind of chips are there, how those tiny devices are fabricated in a single wafer or a chip, कैसे होता है ये सब, कोई नहीं सोचता है। बस हमें गेट में रैंक लाना है, बस, ठीक है? रैंक लाना है, लेकिन सब्जेक्ट को कैसे पढ़ना है ये भी पता होना चाहिए, ठीक है? तो आपको इस सेशन से काफी मजा आने वाला है, ठीक है? दैट आई विल मेक श्योर। सो आप देखते हो कि जो आजकल क्रिकेट मैच भी होते हैं, नाइट में होते हैं, राइट? हाउ दिस बिग लाइट्स आर देयर, ओके, बिकॉज ऑफ सेमीकंडक्टर। White LEDs are lighting up entire stadium. Okay, there are many things. So my question is, as we have metal, insulator and semiconductor, okay, but why this only? Why not these two? What is the metal? What is metal? What is metal is basically a conductor, that conducts electricity. Everybody knows metal is what? The conductor that conducts electricity. Insulator is what? Insulator is a bad conductor of electricity, which does not allow current to flow, in fact. Okay, now people always talk about insulator has this big energy gap. जब एनर्जी गैप की बात आती है लोग बता देते हैं कि इसकी एनर्जी गैप इतनी होगी। नहीं, you can never tell the energy gap of an insulator. You can only assign, okay, 5 electron volt or 6 electron volt. How can you measure the energy gap of insulator? Okay, it is not possible, right? And metal is what? Metal is basically a kind of conductor which conducts electricity. Okay, so guys, one more thing I can say, can you turn off the metal? You can't use metal as a switch. Okay, can you turn off the metal? You cannot turn off the metal, right? That you have to keep in mind. Okay, you cannot block, in fact, the metal, right? So an insulator is already a bad conductor of electricity, so your goal is not fulfilled. Then if you're going to use insulator, then what will happen? You cannot allow the current to flow through the semiconductor, right? The transport mechanism will not happen. So a great candidate which is waiting you to say is semiconductor. Why semiconductor? Because semiconductor is a kind of material. Keep this mind, keep this definition, okay? Semiconductor is a kind of material, okay, whose conductivity can be tailored or tuned, right? whose conductivity can be tailored, right? Tailored, or you can say tuned. Okay, whose conductivity, or you can say can be changed or tuned or tailored by some means, okay, controllably. Okay, now what is conductivity? Conductivity is nothing but what? If you know the resistance, voltage upon current is the resistance, and the reciprocal of that resistivity, the property of material, okay, is known as the conductivity, right? So why we are talking about conductivity? After all, if you talk about conductivity, so you are talking about current only, right? After all, we want current. Okay, this conductivity is related with the current. Okay, more conductivity, the current will be there, okay, in the semiconductor. Now the thing is, metal already has huge conductivity, so you can't change, you can't tailor, you can't tune the semiconductor. Okay, sorry, you can't tune or tailor the conductivity of a metal, right? Semi insulator is already bad conductor of electricity, right? So needless to try. But you will find in future when we will talk about electronic devices, insulator will be also playing a vital role, okay, to reduce the leakage current and all, right? We always go for SiO2 layer, silicon dioxide layer. There are many kind of layers, right? Hafnium dioxide, okay. So remember the semiconductor. Why semiconductor only? Because semiconductor is a material whose conductivity can be tailored or tuned by some means, controllably, in a controlled fashion, okay, in a controlled manner, right? So there is only one guy, one candidate which can allow high current to flow, which can allow less current to flow. Okay, means you can control everything according to your need. Okay, if you want, now the question is how to change, how to tune conductivity of any material, right? This question might be coming in your mind. ये question आपके mind में आ रहा होगा कि किसी material का हम कैसे कंडक्टिविटी बदल पाएंगे. कैन समबडी टेल मी सम ways of tuning or tailoring the conductivity of a material? Anybody? सेमीकंडक्टर की हम कंडक्टिविटी कैसे चेंज कर पाएंगे? ऐसे कौन कौन से मेथड्स हैं दैट यू शुड नो, राइट? So one method is doping. Okay, doping is a mechanism, okay, by which we'll try to tune the conductivity of a material, okay, of a semiconductor. ठीक है. और मेन सबसे जो इंपॉर्टेंट यूज है सेमीकंडक्टर का, दैट इज सेमीकंडक्टर इज यूज्ड एज अ स्विच. सेमीकंडक्टर is used as a switch. Okay, इसका हम लोग स्विच की तरह okay यूज करते हैं. You might have seen diodes are used. Yeah, you can raise the temperature, okay, you can change the conductivity. Yes, doping is one of the mechanism, okay, right? Doping, we will prefer doping here, understood? Or by shining light. If you shine light on a material, right, if you shine light on a material, you can change the semiconductor conductivity, right? So automatically, see, don't take anything as a topic. Okay sir, doping क्या होता है? डोपिंग लिखो बच्चों, डोपिंग नहीं. क्यों? why doping? Why do we need doping? Because this semiconductor is there, right? This semiconductor is permitting you to to make revolution in the world, right? In terms of power reduction, right? You can reduce power. Okay, see, LOLEDs were consuming a lot of power, right, earlier, but now white LEDs are there. Why white LEDs are spreading in the market? In all the stadiums you see, in all the roads, okay, you go to any place, okay, people call them call those kind of a city like they are making smart cities. ठीक है, क्यों? देखो वो पावर कंज्यूम बहुत कम करते हैं, ठीक है, ये बिकॉज ऑफ दिस सेमीकंडक्टर ओनली. दिस सेमीकंडक्टर इज सच अ ब्यूटीफुल कैंडिडेट. ठीक है. So if you're able to tune, okay, if you're able to suppose there are two people, ठीक है, one people is there, you want to take that people and you want to run him according to you, right? And one man is there, he's not going to be run by you, okay? He's not getting convinced. Whatever you say, he's not going to convince. He's going to do his own work, right? So whom you going to prefer? The man who will follow you always, right? ठीक है. तो सेमीकंडक्टर एक ऐसा इकलौता यू कैन से आइसोलेटेड कैंडिडेट है जो कि लाइफ में बहुत ही बड़ा यू नो रिवोल्यूशन लाने वाला है. ठीक है. तो टुडे यू आर एबल टू वॉच माय लेक्चर्स, यू आर एबल टू कैप्चर वेरी गुड सेल्फीज. ठीक है. आप मैक यूज करते हो, आप मोबाइल फोन यूज करते हो, आप इतने अच्छे से लैपटॉप्स, मोबाइल फोन लाइक आईफोन, एवरीथिंग. ओके. ये क्या है? ये सब सेमीकंडक्टर. अगर सेमीकंडक्टर नहीं होता तो टुडे पीपल आर टॉकिंग अबाउट एआई, मशीन लर्निंग, नथिंग इज पॉसिबल. ओके. इफ सेमीकंडक्टर इज नॉट देयर. ठीक है. ओके. तो this property is only the semiconductor is having this unique property, okay, that it can both allow very high current to flow, okay, and it can also block very large voltage. Okay, remember, it can also block very large voltage. Okay, so these are the properties. So these are the unique properties. ठीक है. What are the unique properties? It can allow high current to flow. Okay, it can allow high current to flow, and it can also block very large voltage. Also block very large voltage. Okay, so what you can say, just like insulator does. Okay, so you can say that this semiconductor will be used as a switch, and it will be also used as a amplifier, okay, which you will see in future. So there are many applications, right? It can be used as a switch. I'm just writing some applications. The switch, okay, it can be used as an amplifier. Okay, it can be used as a logic memories. Okay, I think everybody is familiar with what is the need of memories. Memories are used to store information. Logic memories, okay, and switch can be on, switch can be off. Okay, these are the properties that semiconductor have. Okay, always keep this in mind. But metal and insulator does not have. So there are other there are other advantages, there are other parameter to talk about. One is energy gap. Okay, if you understand the concept of energy gap, you can say that the energy gap of semiconductor is very less compared to the compared to insulator. Okay, though metal does not have any energy gap. Okay, both the bands will be overlapped. Okay, so one of the parameter is also there which isolates semiconductor as a great candidate. Okay, that is energy gap also. So in terms of energy gap, you can classify the semiconductor. In terms of doping, you can classify the semiconductor. There are various concepts, right? So what I'm going to do here is I will talk about classification. So if somebody will ask what is semiconductor, so I think everybody should be able to tell. Semiconductor is a kind of material whose conductivity can be tuned or tailored according to the need, okay, in a controlled manner or in controlled fashion, you can say. Okay. And what are the uses of semiconductor? You can tell n number of applications, right? The mobile phones, the white LEDs, right? The amplifier. You can talk about logic memory devices to store informations. Okay. अब AI आपको पता है, right? उसके पीछे कितना डेटा है, how data are processed, right? You go to data center, you see the memory devices. Okay, 1 giga 1 terabyte. Okay, so big memories are there. This semiconductor material should be very great. Okay, so you have to understand. चलो नेक्स्ट बात हम लोग करेंगे कि सेमीकंडक्टर क्लासिफाई कैसे करते हैं. क्लासिफिकेशन ऑफ सेमीकंडक्टर ओके material. How to classify semiconductors? See, remember always there are two ways to classify semiconductor. One way is in terms of doping, right? So semiconductor can be classified into two ways. Okay, one way is what? In terms of doping. In terms of doping. Okay, what is the meaning of doping? That we will understand. Doping will be nothing but what? If you add external impurities to the semiconductor, right? Because semiconductor will be basically classified as what? In terms of impurity or doping, you can say, right? So first will be in terms of impurity, okay, and in terms of number of element, right? Number of element. Okay, so impurities means what? Suppose your material is so pure, if there is no impurity at all in the material, it is not possible, guys. Okay, it is not possible. ये possible ही नहीं है. ठीक है, कोई भी सेमीकंडक्टर इतना प्योर तो नहीं हो सकता, उसमें कुछ ना कुछ क्या होगा, there will be some impurity. So your semiconductor is of two kind. First is what? The intrinsic semiconductor. Intrinsic semiconductor. Okay, उसके पहले प्योर काइंड ऑफ सेमीकंडक्टर है. रिमेंबर, प्योर. ओके, व्हाट इज द मीनिंग ऑफ प्योर? प्योर मींस प्रिस्टाइन. ओके, प्रिस्टीन, 100% purity. Okay, but it is not possible. You can say 99.9%. And suppose there are some impurity inside the semiconductor, right? So intrinsically you are able to compensate that impurity, so that is known as intrinsic semiconductor. See, intrinsic semiconductor is nothing but a pure semiconductor only, right? But if you bring some impurity into the semiconductor, okay, now I think you know why do we need to add some impurity into the intrinsic semiconductor. See, initially you will always imagine what? Okay, my semiconductor is so pure, right? 100% is not possible. Suppose there are some impurity. Okay, so if you're able to intrinsically means internally, right, compensate those impurities, right, and make it pure, that becomes an intrinsic semiconductor. So you can say intrinsic semiconductor is pure kind of semiconductor, right? And when you do external addition of impurity, okay, external addition of impurity, okay, from the external world, that then your intrinsic semiconductor becomes extrinsic. Okay, so from the name itself you understand here the word ex is there. What is the meaning of ex? Externally you are adding what? Impurity. You are making your semiconductor impure. क्यों ऐसा कर रहे हैं? क्योंकि we have to tailor the conductivity. Now question is, why do we want to tailor the conductivity? हम लोग क्यों कंडक्टिविटी को चेंज करना चाहते हैं अपने अकॉर्डिंग? अब आपको पता होगा, क्योंकि आफ्टर ऑल हमारा गोल क्या है? कोई भी डिवाइस से करंट फ्लो होना चाहिए. ठीक है, अगर डिवाइस में करंट फ्लो नहीं होगा, करंट आना चाहिए. अब टू हैव अ करंट यू नीड टू इंक्रीज द कंडक्टिविटी. ठीक है, तो ये कंडक्टिविटी एक बहुत ही इंपॉर्टेंट पैरामीटर है. Tanish, sir, so many persons say that if India manufactures silicon, then it is not good quality. What is your call? See, the thing is, how do we get silicon? Can somebody answer me? How do we get silicon? Okay, see, in India the main problem in India is what? We don't have any fabrication lab apart from academic labs. Okay, if you go to IISc Bangalore, from where I did some project work, okay, so if you go to Sense department, the Center for Nanoscience and Engineering, right, so you will find one lab over there, to house a lab, to to have a lab, or you can say to establish a fabrication lab, the cost is going to be very high. Okay, the semiconductor lab, okay, I'm talking about that clean room. Okay, the cost of establishing clean room is very high. Okay, so in India, yeah, from the sand, yes, from sand we get silica, and we process the silica. Okay, then we get silicon, right? And then from the silicon we get wafers and all. So you need a clean room to process your sand, because in sand there will be a hell lot of impurity, you can say, right? Okay, it will not be clean at all. Okay, so in fact we have got ISRO also, SAC is there, right? So there is one more semiconductor lab, but now Intel is also planning now to open a fabrication foundry here in India, right? Because it is very high, it is very costly affair, right, to establish a foundry in India, right? So that is the reason still we are not but now we are growing up. Okay, now many investors is going to come, and the government of India is welcoming them, right? So they are going to invest here, right? So a million of opportunities will come across. That is the reason you might have seen in different IITs and ISC, the number of seats also gone up this time. Okay, in ISC Bangalore this year they are taking 59 to 60 student, okay, from 27. Okay, earlier it was 27 only. Okay, so there is a need of semiconductor, only we have to understand the basics. ठीक है, फिर हम लोग इसके बारे में बात करेंगे. So quality wise, don't talk about quality wise and all. Still in India, yes, yes. If somebody gets an opportunity, one of my in fact friend was there. He was the topper of GATE 2013, right? So yes. So what they do is, if you're getting an opportunity across, you will go there, right? But if some kind of opportunity will exist in India as well, you will come back and work there. It depends upon the opportunity, right? That's it. So in terms of impurity, if you want to classify the semiconductor, so there are two kind of just wait, yeah. Now we are connected, right? So pure means what? 99 or 100%, right? So here what we say that actually we got disconnected. So again, I'm just going to talk about this, right? So intrinsically, if you're able to compensate, okay, like if I ask you, you are a good man, you will say yes, sir, but there will be some negativity, right? But if you're able to manage those negativity, you can consider like this. Okay, so intrinsic semiconductor, right, the pure kind of semiconductor, pristine or pristine. Okay, extrinsic, why we call it extrinsic? Because external, externally we are adding some impurity, right? So if you're going to add some kind of impurity, so further we will classify extrinsic semiconductor as, we'll say, N type of semiconductor, okay, and the P type of semiconductor. We'll say what kind of impurity we will add here. Just wait and watch. Okay, so semiconductor can be classified in two ways. One is the in terms of impurity, okay, the intrinsic and extrinsic, and one further classification is number of element. How, what we are talking about? How many number of element? What is number of element? What kind of element I'm talking about? If you go to periodic table, okay, periodic table, okay, I will not talk about full periodic table. I'm just going to talk about partial periodic table, right? I'm just going to focus on one of the partial periodic table, okay, part of the periodic table, you can say, right? So can somebody tell me that the semiconductor belongs to which group of periodic table? Anyone? Tanisk, other people like Arjit. Suppose I say that this marker is a semiconductor, guys. Okay, how can we say that this marker is a semiconductor? Anyone? The very first identification, how can you understand? So the very first identification, if you want to talk about, this is a semiconductor. Suppose Dheeraj sir is a semiconductor. Okay, how can you say Dheeraj sir is a semiconductor, or this marker is a semiconductor? If this marker belongs to the fourth group of periodic table, remember the fourth group of periodic table, okay, In all the reference book, you will find that the partial periodic table is given. They never give complete periodic table, okay? But in chemistry, you will find complete periodic table, okay? That is the reason if you want to become a good semiconductor expert, okay, you need to be having the knowledge of chemistry as well. You need to be having the knowledge of material, okay? The combination of all these will make you amazing in your career, right? Perfect. So the fourth group of periodic table has got has got element, okay? Keep this in mind. This will be carbon, silicon, germanium, okay? So germanium. And if I talk about this group, this is the third group, okay? The neighborhood of the fourth group is going to be third group, and this is again the fifth group, okay? So what are they? Can somebody tell you what are the elements which are present in the third group? Huh? The boron, aluminium, gallium, okay, indium, right? And here there will be, you can say, phosphorus, arsenic, antimony, bismuth, okay, like this. Okay, so I believe this is fine for everyone. So see, if you pick up one element from the periodic table from the fourth group only, that kind of semiconductor will be known as what? That kind of semiconductor will be known as elemental semiconductor. Okay, elemental semiconductor. Okay, because only one single element we are picking up from the fourth group of periodic table. So when suppose I give you one complete periodic table, and if I ask you, can you put your finger on the semiconductor, you should directly put on the fourth group of periodic table, right? You should be able to identify. जैसे map होता है ना, Indian map you take, okay? If I ask you where is Bangalore, you will say there is a Bangalore. Where is Madhya Pradesh? So you will say yeah, this is Madhya, or Rajasthan, wherever, right? Okay, just like you should be able to identify where is semiconductor, where is this favorite candidate, कहाँ पर है ये, इसके बारे में हमें पढ़ना है. समझ आया क्या? बस माइंड में इतना मत रखो कि यार फॉर्मूला रटना है, ये सर ने ऐसा बताया था फॉर्मूला रट लो, ये सब भूल जाओ. अंडरस्टूड? That is the reason I started all the subjects. And before you can say October, everything I'm gonna finish, and you will play with the subject, guys. This is my promise. Okay, so you see, this is a fourth group, and if you pick up one element, okay, see, in fourth group you will find that carbon is also present. Okay, carbon, silicon, germanium, right? But carbon will not be considered as a semiconductor, guys. Okay, there will be some reason. Okay, nowadays graphene is present. You will find graphene as a semiconductor as well, right? So carbon is also used somewhere, but carbon is not regarded as semiconductor, right? उसका क्या रीजन है? That reason is named as energy gap. क्योंकि कार्बन का जो एनर्जी गैप होता है वो बहुत ज्यादा होता है, ठीक है? And silicon, why we always prefer silicon as a semiconductor? हमेशा, because first of all silicon is abundant. Okay? सिलिकॉन बहुत ज्यादा मात्रा में अवेलेबल है, सबको पता होना चाहिए, ठीक है? ओके, सिलिकॉन इज रेडली अवेलेबल, ओके, बिकॉज सिलिकॉन वी गेट फ्रॉम द सैंड, ठीक है? So if you take this fourth group and fifth group and combine them, okay, so that becomes a compound semiconductor, right? So there are two kind of semiconductor, okay, in terms of element. If you are going to classify, तो पहला क्या हो जाएगा? elemental semiconductor. If you take one element like you can say silicon or germanium, ठीक है, इसको हम लोग बोलेंगे elemental semiconductor, or we sometimes call it simple semiconductor, simple, okay? And second kind of semiconductor is basically the compound semiconductor. Compound, I think from the word itself you are able to understand what is the meaning of compound semiconductor, guys. Compound semiconductor means you are taking one element, you can say I'm just going to take here, right? You can take one element from here, gallium, Ga, and one element from the fifth group, that is arsenic. So this formula is known as gallium arsenide. Okay, gallium arsenide. Okay, gallium arsenide. So this compound semiconductor has also got very beautiful application in optoelectronic devices guys. ठीक है, तो आप तो देखो कंपाउंड का मतलब क्या होगा, दो एलिमेंट होंगे, देयर कैन बी थ्री एलिमेंट, देयर कैन बी फोर एलिमेंट, राइट. You can make the semiconductor of any kind, right? Only you have got third, fourth, fifth. Fourth क्या होगा, fourth if you take, that will be regarded as semiconductor, right? The elemental semiconductor. Okay, now further, okay, अब जैसे suppose you are not happy with the silicon, right? Silicon devices are consuming lot of power. Okay, so what you will do, being an engineer, there are some metric. Okay, there are some metric where we always focus. क्या कहाँ फोकस करते हैं, लेस पावर, पहली बात, लेस पावर. ओके, वी ऑलवेज फोकस ऑन मिनिएचराइजेशन ऑफ डिवाइसेस, छोटा डिवाइसेस होना चाहिए, ठीक है. ओके, स्मॉल डिवाइस, वी वांट स्मॉल डिवाइस. ओके, राइट, स्मॉल कंप्यूटर, लेस कॉस्ट, कॉस्ट शुड नॉट बी वेरी हाई. अब यार कॉस्ट कैसे मैनेज करोगे, साइज तो स्मॉल हो गया, कॉस्ट कैसे मैनेज करोगे, when power will be, you know, the power consumed by the device will be low, right? So keep this in mind. So you need to invent some material as well. So you go to the periodic table, you see, okay, this guy is there, this guy, let's try. Okay, ये कौन करता है, मटेरियल साइंटिस्ट. अच्छा ठीक है, गैलियम लिया, आर्सेनाइड लिया, ओके फाइन, यस, मैजिक, we have got the formula gallium arsenide. Okay, now gallium arsenide is what, gallium arsenide is going to make revolution. अब देखो गैलियम लिया एंड नाइट्रोजन लिया, गैलियम नाइट्राइड, अरे बाप रे, you know, you go to ISC, people will always talk about gallium nitride, GAN, 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 ठीक है, GAN की बात कर रहे हैं, GAN डिवाइसेस, HEMT, ओके, high electron mobility transistor devices. Okay, you go to ISC, people will talk like this only. ठीक है, वो दिन भर यही बात करते हैं, बस यही बोलते हैं कि material scientist, this, he is a material scientist, he is the, you know, chemical scientist. Okay, he is a semiconductor. Okay, so if you go to device area, so you will be having all kind of exposure. Okay, चलो, तो याद रखना सेमीकंडक्टर को हम लोग क्लासिफाई करते हैं दो तरीके से, टू वेज. ओके, वन इज सपोज दिस इज सेमीकंडक्टर, so in terms of impurity, okay, this is, you can say, intrinsic. Okay, and this will be extrinsic. I've told you the reason why do we call it intrinsic, why do we call it extrinsic. Okay, and you can also classify semiconductor as like elemental semiconductor. So if I belong from the fourth group of periodic table, then you can also say me, I'm a semiconductor. No, ऐसा भी नहीं है, because there is a carbon sitting man, carbon is smiling. Okay, you should do further, you should investigate further properties, right? कि energy gap. Okay, so अब yeah, to understand energy gap, you need to have the knowledge of bands. उसके बारे में हम लोग नेक्स्ट क्लास में डिस्कस करेंगे, ठीक है, because this is the first class where I wanted to introduce you who am I, how I'm going to proceed for semiconductor, right, and how much I like semiconductor, guys, and I want you to start liking semiconductor, because without semiconductor your life is not okay. हाँ, see, in the village when there was no electricity, लालटेन was everything. हमारे केस में तो लालटेन था भाई, लालटेन अच्छा था. अभी क्या है, now I'm in Bangalore. Okay, so I need to have good mobile phones. देखो पैसा है, it's okay. Suppose you have a money, you just go and buy iPhone. But I want to, you know, learn why this iPhone is capturing great pictures. ठीक है, okay, तो उसके पीछे क्या स्टोरी है, that semiconductor. ठीक है, तो ये सब जानना जरूरी है. तो एलिमेंटल सेमीकंडक्टर मतलब सिलिकॉन, जर्मेनियम, and then you talk about compound semiconductors. Okay? Compound semiconductor, these are not readily available, you need to make it, right? Gallium arsenide, okay, indium phosphide. Okay, so these kind of semiconductors are used as a, you know, optoelectronic devices. Okay, To fabricate optoelectronic devices, we go for compound semiconductor, and to fabricate like simple devices like p-n junction and all, okay, we go for silicon. But why silicon? In the next class we'll discuss why silicon, why not germanium, why silicon is a silicon, right? Okay, in the syllabus also you'll find that semiconductor, silicon, okay, they always talk about silicon, right? So this is what I wanted to discuss, and we'll talk about more concepts. So in future you will find that elemental semiconductors are known as indirect band gap of semiconductor. Compound semiconductors are known as direct band gap of semiconductor. Again, on what basis I am telling this? What is that basis? Because of that I am telling, oh, compound semiconductor is a direct band gap of semiconductor. देखो यार basis नहीं पता, don't say, ठीक है? Suppose in the interview I ask you, compound semiconductor is indirect band gap or direct band gaps? You will say, sir, it is direct band gap. Then I will say, how you are saying? Can you explain? You will say, sir, बस खत्म, दूसरा कैंडिडेट आएगा, ठीक है? And this happened with me. Okay, so you have to be ready now. Okay guys, so we'll meet in the next class. Thank you so much for today, and we'll meet and we'll discontinue our session. Okay, we will be talking about bands and band diagram. Okay, and we'll talk about one of the very important parameter, that is energy gap. Okay, this energy gap is very, very important, right? And then our life will start. Right now I'm not talking about how whole, what is electron. पहले आपको बेसिक पता होना चाहिए, ठीक है? चलो ठीक है, thank you so much guys, keep learning, and we'll conduct